I'm just going to close this door before I get going because there's someone talking outside. Oh, hi everyone, welcome to this AimHi Live. So in this AimHi Live, we're going to be talking about how to build a star. I'm just going to bring up the chat so I can see who's chatting. Welcome on if this is your first time. Thanks so much for coming. I'm just going to load this up. If you're just joining the chat for the first time, then say hello. Hi Mia, welcome. Hi Jeff. Jeff, don't worry about missing this morning. This morning was just a test run. We were just testing to see if we should do it in the morning, but I think I'm going to stick to the afternoon. Hi Jasmine, welcome back. Yeah, if you're joining for the first time, get involved in the chat. There's a really nice community building up in there. So like, throw questions in, throw comments in, reply to what other people are saying, and steer the direction that this is going to go in. And yeah, if you're here for the first time, then this one is about fusion and how to build a star, but that doesn't necessarily mean it's going to start about that. Oh, Sam from Leeds is back. Hi Sam from Leeds. And the Pumpkin Master, before I forget, can I request a live on magnets and or lenses law? Yeah, 100%. Okay, can you write that to the Instagram? Because then it'll go on a record where we're like keeping track of what people want. And then it'll be easier to stay on track of what people want. And I'll do one on magnets because magnets are really cool. I need to do one on why the pole is going to flip. I don't think I've done that yet, have I? I don't think I've done that, no. I'm going to do one on why the magnetic pole of the Earth is going to flip soon as well. But yes, I agree, magnets are cool, and we've got to do a live on one soon. Okay, so today's live is... so I kind of started doing this morning, but I'm going to do it with much more stuff than this morning, because this morning my internet was broken. So, here we go. The first question is... oh, and Mia, yeah, if you don't have Instagram and you want to write in, then there's also a Facebook page. That's AimHi Live with an S on the end. I'm AimHi Lives. So you can message in on that. Or there's also an email address on the website, aimhi.co, I think. Okay, so today's live is about fusion and how to build a star. So I thought I'd start this off, as all good lives about fusion and star building, with a quick picture of a seal. So here is that picture. So what is the most opposite mammal to a seal? What's the most opposite mammal to a seal? Now, this question does not really have a real answer because I don't really think there is. I don't really think the question makes sense. But I'm interested to know what you guys think the most opposite mammal to a seal is. Someone came up with a great suggestion this morning for what it should be. And while I'm just waiting for those answers to come in, if you're just joining, this is an AimHi Live, so you can ask questions whenever you want and get involved and steer the direction that we're going in. And it's a bat. Bat's such a good suggestion. Horse is good as well. The one this morning was a giraffe, which I think is pretty good. Anyway, right, so if you take the most opposite mammal to a seal, or if you literally just took the two most different mammals that exist, which could be like a little baby seal and a big giraffe. Oh God, why have I started drawing a giraffe? I'll carry on. I'm so bad at drawing things. Anyway, that'll be our giraffe for the day. So if you take two really different mammals, like a seal and a giraffe, and then you also compare them to a bee and a wasp, which of the two do you think have a bigger difference in their genetics? A bee and a wasp, or a seal and a giraffe? What do you guys think? Give you a moment to throw down some answers. Hi Mariella, just coming in with human and bat being like two of the most different kinds of mammals. Yeah, humans and bats are pretty different. I'm actually not sure what the two most different mammals are in terms of genetics. But Miz has come in with being a wasp because I'm onto your trick questions. So it's Mia. Yes, bees and wasps are so different genetically. Okay, other question. I know this is not related to fusion and how to build a star yet, but it will be one day. Other question. What do you think is more related to ants, bees or wasps? Roxy's come in with Leonardo da Vinci, but I don't know what that's an answer to. Wait, what was that an answer to? Different mammals to the seal. That is a different mammal to the seal. I would say seal and giraffe, but I think it's bee and wasp. Yeah, it is. It is. Bees and wasps are the most are really genetically different, like way more so than any mammal. And ants are really closely related to wasps. Yeah, which is part of why wasps are so cunning, even though they're so horrible. I hate wasps, but they do some good things. You know, they are an important part of the ecosystem, as annoying as they sometimes are. But guys, learn to recognize the difference between bees and wasps. I was at this festival one year, and there was this woman just attacking a load of bees, and I was like, no, they're bees. We like bees, and we kind of like wasps, all right. But she was like, no, they're wasps. Anyway, no, learn to recognize the difference. Key bit of knowledge. Okay, so. This is going to be about fusion. So fusion is kind of like a dream, and it's something that people... I'm just going to scroll over to this fusion-y thing. Fusion is kind of a bit of a dream in the sense that if we can get it working, then theoretically we could power everything like really cheaply and really in a way that's much more green. Because with fusion, you know, when we're trying to power like power stations, we burn stuff like coal and oil and gas, right? But what is the fuel for fusion? Does anyone know? What fuel do we use? Roxy, you were complimenting my artwork by saying it was Leonardo. Thanks, mate. Yeah, I did. I have spent many years dedicated to the art of drawing giraffes, so I really appreciate that. Okay, Jeff's saying nuclear power. So nuclear power is not the fuel for fusion. Nuclear power is what people talk about when they're talking about fission. And there's a difference between fusion and fission, which I'll come on to in a sec. Fusion versus oh god, I'm so rubbish at typing. Fusion versus fission. We will talk about those in a mo. But a lot of people are saying hydrogen. Yeah, okay, hydrogen. So hydrogen is the main fuel that's normally used for fusion, but actually there are loads of different things you can use to make fusion work. The key idea is that the fuel for fusion is just matter. It's just stuff. Like all you need is stuff, and you can make fusion happen. Now you do need a certain kind of stuff, but the world is literally made of stuff, and so there is so much fuel for us to use, which would save us from burning a fuel which is currently also destroying the planet. And Fatima's coming in saying it's a hydrogen isotope. And Mears is asking if there's a difference between fission and fishing. Yes, Mears, there's a difference between fission and fishing. Anyway, right, so yeah. So there's a certain hydrogen isotope that is normally used in fusion, which we shall come to in a sec. I will get, and if people don't know what an isotope is, I'm just writing it down. An isotope is like the same version of an element, so it's still a hydrogen, but it's just a different heaviness. It's got a different number of neutrons in it, so some isotopes are heavier and some are lighter. Right, okay, so yeah, if we can get fusion working, then it would be amazing because we could power loads and loads of stuff on the planet, which we currently can't really power. So this is an example of one. This is called a plasma waste converter. I don't know if anyone's ever heard of these before, but does anyone know what these do? Plasma waste converter. And I feel like there's an O in there that I've missed, convertor maybe, but I can't spell. Does anyone know what a plasma waste converter does? It's something which we've invented, but there's currently no point in running them in most cases because they're just too energy intensive. Jasmine is also asking, why is fusion so good and does it have a waste product? And I will also talk about that in a mo. So Jeff's saying they look like it could be rocket engines, and yeah, they are. They are producing a huge amount of energy. So these things get up to a temperature of about 13,000 degrees. I have no idea what that would be in Fahrenheit. Sometimes people ask me for Fahrenheit measures, but I don't know. But basically crazy hot, like way hotter than the surface of the sun. And what they do is they are used to convert rubbish, like, or garbage in American English, or whatever you call it. They used to convert rubbish into useful things. So you can literally put anything in here. And one of the key things that will, like, a lot of people will think is pretty cool is that you can put plastic waste in these things. You can put any kind of plastic waste, and it will heat it up to such a high temperature that it will release this thing called synthesis gas, which is like a mixture of various different gases. Synthesis gas that you can use to then make useful things, like you can make more plastics, or you can make pharmaceuticals, or you can make like all kinds of stuff. And it gets rid of any of the waste that you really don't want to produce, and it just produces these very, very pure products. Plasma waste converter is going to be the future of getting rid of waste, but at the moment we just can't afford the energy to power them. But yeah, that's one of the cool things we can do with when we have fusion online. Another thing we can do is, have you guys ever... Yeah, Mariam said it turns stuff into gases. Exactly. So it turns stuff into these useful gases called synthesis gas. So another useful thing we can do is, I maybe talked about this on my Instagram, but I'm wondering if people know. In fact, I've forgotten what it's called. It's maybe called like solar foods or something like that. Has anyone heard of this project that's been going on in Finland to create food with solar energy? Just while I'm waiting for people to see if they recognise that, Jasmine's saying, if we all traded in potatoes, do you think the world would be more peaceful? What if we're all trading with potatoes? Maybe. But what about if you do need to like save up for something? Because all the potatoes, maybe the world would be more short-termist if everyone was trading in potatoes, because the potatoes are kind of rot away, right? Potatoes might not be the solution, but I would be up for trying a potato-based economy at some stage, because it'd be fun. And anyway, so Jeff's saying, can't plants do that with photosynthesis? Turn light energy into food. So let's go back to that. So yeah, Jeff, you're absolutely right. But the conversion rate of turning light energy into food for a plant is really variable, and the highest I've ever seen is something like 8% of the energy captured. So 8% of the sunlight that falls on the plant can be turned into food, and I think that's with sugarcane. Whereas with plants producing more complex kind of stores of food, they're really not even capturing 8%. They're converting closer to like 1% of the light energy that hits them. In comparison, these people in Finland have found a way to use a solar panel that can capture sunlight and convert it to electricity, and you can use the electricity to feed little bacteria that are growing in a plate at the bottom. You can feed these bacteria literally just like electrons and bits of, again, synthesis gases. So coming back to the stuff that you get off a plasma waste converter, but you can get it from other places too. So feeding them electrons and synthesis gases, and you can convert 50% approximately. I think it's up to at the moment. It may only be 30, but still it's significantly higher than plants. I think it's about 50% of the energy you can convert to food, to like mass, edible mass in these bacteria. And yeah, sure, you're eating bacteria, which could be a bit rubbish. But on the plus side, you're creating food with incredible efficiency. And we can start to do this even more if we can scale things up with things like fusion. So what other cool things do people think we could do with fusion if we could bring fusion online? I want to know what things you think. And just while you're answering, I'm just going to have a quick look at the chat, because it looks like loads of people have been saying stuff. It's all about potatoes. Guys, we're trying to learn about fusion here. Okay, so people are big on potatoes. Yeah. All the chat is about potatoes, right? I'm going to move on to what we're actually covering. So, much as I always appreciate potato chat. Okay, so we're gonna move over to down here. What is this? What do people think this is? And your clue is that this is in Alaska. And actually, someone just said that you could power fusion with potatoes, and that is absolutely right. I'm about to come on to something really similar to that, and I was going to use a different example, but we will use potatoes in honour of what's been going on in the chat. So Pumpkin Master says fire, correct. All the points to Pumpkin Master. And Jasmine is coming in with a longer answer, which has got more in it, which is correct as well. So yeah, this is the gas being released from the ice. Does anyone know what the gas is? This isn't geothermal energy. Geothermal energy is when you put a big water pipe deep into the ground and it picks up the heat from underground, like the volcanic heat, and then it brings up boiling hot water, and that's how you do geothermal energy. But that's not this, because geothermal energy does not normally have any fire in it. So Jasmine's come in with methane, and so is Mia Doan as well. Welcome back, guys. So yes, this is methane being released from the ground, which I'm just going to label as CH4. Why would there be methane in the ice? Why is there methane in the ice? Pumpkin Master is saying cow farts. The theory being presumably that cows have polar bear farts. So there's a lot on farts. Actually, it's a bit of a myth, you know, that it's all from farts. Polar bears would not release anywhere near as much methane. The reason why cows release loads is because of the way that they digest grass is so inefficient. It's kind of magic because like most animals can't digest grass, and so cows are this amazing thing that can take grass and use it and convert it to something. And so that's why humans have been so obsessed with cows for thousands of years, because they can like turn the grass into like milk and leather and power to pull plows and all this kind of stuff. But they do it so inefficiently, and they release loads of methane when they're doing it, but it's not farts. Does anyone know where most of the methane comes out of cows from? And meanwhile, I'm just going to look at some of the other answers. So Mirdone is saying dead organisms decomposing without oxygen, and Izzy is talking about anaerobic decomposition as well. So yes, there is a degree of anaerobic decomposition which is going to create some of this methane. A lot of it is also trapped in the ice from previous atmospheres. So we used to have atmospheres that had different compositions of gas. And so back when the ice was forming, this area of ice stored loads and loads of CH4. And we call these things Methane Clathrates. It's the like complicated word. You don't need to remember the name, but just if you're interested, that's what it's called. And these methane clathrates are full of methane, and as they melt, they release loads of methane. And Izzy Rose is coming in with burps, and Jeff's coming with burps as well. Exactly, yeah. Most of the methane from cows comes from their burps. It's part of the way that they're digesting it. Right, okay, so methane is quite bad, as methane is a greenhouse gas. Does anyone know, can anyone rank in order what they think the most powerful greenhouse gases are out of the following? So carbon dioxide, methane, and water. So water vapor. What do people think are the most powerful greenhouse gases, and what do people think are the less powerful ones? Put them in order from most powerful to least powerful. And why does the methane set on fire? I just saw Roxy ask. The methane sets on fire because some scientists have dug this hole and set it on fire to demonstrate how much methane is leaking out, to show that it's in motion. Because normally the methane would be locked into the ice, be stuck there, but as the ice is melting, it's pouring out, and they're demonstrating this because they wanted to take a picture to show people how scary this is, because it's actually really scary that there's so much methane pouring out in the north. Anyway, what order do people think from most powerful to least powerful? So the answer is Meadowen is the only one who I can see who's got it right. So water vapor is the most powerful of the greenhouse gases, which is really shocking, isn't it? But it's only over a short period of time because water vapor doesn't stay in the atmosphere for very long, and also it only has a certain capacity for so much water vapor. So we don't need to worry about that one too much. But theoretically, it is the most powerful. Methane is the second most powerful, and that lasts for hundreds of years, and then CO2 lasts for many thousands of years. So there is an argument to say that I'm wrong if you're talking about measuring it over many thousands of years, because in that case, the worst is CO is all reversed. The worst is CO2, then methane, then H2O. But over the short term, it goes 1, 2, 3 in terms of how bad they are. Right, okay, so let's get back to some fusion stuff. And Meadowen's just come in saying sulfur hexafluoride is mad though. Yeah, sulfur hexafluoride is particularly bad. Just to show you what that looks like, it's just sulfur with 6 fluorines attached. Sulfur hexafluoride, and that's used often as like an unreactive gas in wind turbines to help them to spin without any of the metal kind of breaking down. And anyway, the wind turbines themselves let out sulfur hexafluoride, which is ironic, but that's a problem that's being sorted out now, I think. Right, okay, so the sun. Question, why is there actually no fire on the sun? Because it's not actually on fire. What do people think the answer to that is? And yeah, if you're just joining, then you're quite late. That's fine. If you're just joining, we're talking about fusion and how to build a star. And when I say we are talking about that, what I really mean is that we're only just starting to talk about that because this lesson's been quite meandering. Okay, so Jeff's saying because it's all plasma, so it's using fusion, and that's right. So for people who don't know what plasma is, you will know what solid, liquid, and gas are as the different like states of matter. But there's also this other one called plasma, and there's another one as well. But let's not go into that. But plasma is like when all the electrons and protons and neutrons go all like mulchy and like mix with one another when it's super crazy hot, and that's what's going on here on the sun. And yes, there's no oxygen or almost no oxygen on the sun, which is why there's no fire. So it actually isn't a fire. It's a huge fusion reaction. Now, if you were to create a similar sun next door, so over here, and that similar sun were made entirely of potatoes, then which one would be hotter? What do you guys think? And I'll give you just a little bit of time. And meanwhile, Mariella's just said that the sun is not orange, it just looks orange. Yeah, the sun is, there's this chart that you can look at. I've forgotten what it's called. Oh, it's called the black body radiation like graph. If you look at black body radiator, you can see like this graph that shows you what color different stars will be based on their temperature. And our sun is actually kind of in the yellowy range. It's more yellow than orange. Yellow is kind of one of the brightest colors coming off it. But check out the black body radiator graph if you want to check out the colors of stars. And someone was asking, it depends how many potatoes. And Fatima said the same heat. And Fatima's right, it's going to be about as hot. It's going to be about as hot even if you make it with potatoes, which is absolutely mad to think. But the reason why is that all you really need are some nice small elements being squeezed together really, really hard by so much heaviness on the outside, all pushing into the inside, and loads of heat. And you combine those things together, heat, pressure, and small elements, and you will get a star. So, okay, where do you guys think is the... Wait, I'm going to look at the comments in a moment, but I just want to ask a question. Where do you guys think is the hottest place in the solar system? Where is the hottest place in the solar system? So the solar system is like our sun, and then the 8 planets around it, and any of the rocks and all that kind of stuff. And the next thing I want people to ask is, where is the hottest place in the galaxy? So Jeff's coming in with center of the sun. And no, there's just while people are guessing, there's a little bit of chat going on about different coloured wavelengths and how they reach us. And there is an effect. The only effect that the wavelengths really have is that some wavelengths, so by wavelengths I mean colours, some colours of light from the sun don't reach us as directly as others through the atmosphere. There isn't really much of an effect going from the sun to us, but just when it gets to the atmosphere, some colours are like scattered a bit more. In fact, blue is scattered the most, which is why the sky looks blue, because blue is kind of coming at you from the sun, but then taking a really weird route to get to you, whereas red and green come to you more directly. So that's another reason why the sun looks really yellow. But anyway, I'll do another one on that later, actually, to explain colours and things. But yeah, we'll do that another time. Okay, so people are saying the hottest place in the solar system, hottest place in the galaxy. We've got some like center of the galaxy, some Jupiter, some surface of the sun, and Mia saying the Large Hadron Collider. But actually, the closest answer is Izzy. Izzy's saying somewhere near Oxford. And she's right. The hottest place, actually not just the solar system, not just the galaxy, but the hottest place in the known universe is this place near Oxford called the Jet Facility. Now, I've got this, I was going to cut this down because I had this like a video I made ages ago. But yeah, I was allowed inside the center of the reactor. I'm just going to show you what it looks like. So obviously that was only like a really short clip. In fact, there's another clip that's a bit better. Here's this one. That was quite a short clip, but that is the hottest place in the known universe. And it's the biggest fusion reactor that's currently running on Earth. And there you can see it just dying out. The thing that I was circling before is, can you see the white dots all over the place? They might be flashing too fast. But these white dots are basically like neutrons attacking the camera, which are like could easily like really destroy the camera long term. But anyway, yes, I actually can't remember exactly how hot it is. It says in the video, but it's significantly hotter than the sun. And the reason is that in order to build your own star, remember these things that I was talking about, the ingredients you need small particles, you need small elements, you need heat, and you need pressure. And which one of those is going to be the hardest to create on Earth for these gases that we're going to react with one another? What do you guys think? Sam Small's just come in with Jet. Exactly, that is the Jet Facility. And Jeff said, Fatima's asking, how do I get into these cool places? To be honest, Fatima, I just wrote to the people at Jet and I was like, hey guys, can I come and see the fusion reactor? And they were like, yes. And they were really enthusiastic about me wanting to talk about it. So on it, if you really want to go to Jet, just write to them. They might let you go if you talk about wanting to write a story about it and wanting to tell the story of it, because yeah, there's some cool people there. So different gases coming in for pressure and for heat. It's pressure. Pressure is one of the hardest things to create, especially for gas on Earth, because you've really got to squeeze these gas particles together. So how do we do that? Actually, I'm going to come back to that in a mo, how we create all this pressure, because I can see that we are super low on time. But I just want to quickly go over to what I mean by small elements. So obviously, a lot of you will have seen the periodic table, probably most of you before. And the periodic table, you read from top left, you read it left to right. So that's first line, second line, and so on. And so if we put all these lines in order, one after the other, so if we lay out hydrogen, then helium, then lithium, beryllium, boron, carbon, and so on, what do you guys think is the most stable element? Now, this is quite a weird question because often you don't study this until a bit later, but there is one element that is more stable than any of the others, and given an infinite amount of time to evolve, all elements will gradually move towards being this one element. So Jeff's saying helium, which is not right. Sam's just coming in about magnetic confinement. Yeah, that's one of the cool things that's going on in Jet. I'm going to talk to you about that in a moment as well. Just see what people think. So carbon, hydrogen, no. The answer is quite weird, actually. The answer is iron. Iron is the most stable element in the periodic table. Now, if you look at this graph here, this shows you, if you line them all up, so this is starting with the really small ones here, and this is going to the big elements here, then this shows you how stable they are. And as you can see, hydrogen is right down here, and iron is the most stable of them all, and then uranium is over here, and that's a bit less stable than iron. Now, what this says to you is that any of these small elements you can fuse together. So this is what fusion is. God, I can't even only just saying what fusion is. I did this lesson in the wrong order, didn't I? So fusion is when you take two small elements, like two hydrogens, some of you will already know this, and you squeeze them together. And as you squeeze them together, you create a larger element. In this case, it'll be helium. And that releases energy because hydrogen is less stable than helium. Helium will be about here. And actually, potatoes are made from elements around here, like carbon and nitrogen and stuff like that. So you can do the same with them. You can take potatoes, and if you can squeeze them together hard enough and hot enough, then they will blend together. The atoms will literally move in towards one another and move in together to create more stable elements moving towards iron. Now, this takes unbelievable amounts of pressure and temperature. It's not something that happens very often at all on Earth. In fact, yeah, the jet facility is the only place that can do it. Now, I'm going to just quickly answer something that someone else was saying earlier as well, which was about isotopes. So actually, people don't normally use normal hydrogen. They normally use a slightly heavier version of hydrogen. They normally use deuterium, which is hydrogen with one neutron, or tritium, which are like cool names. So I'll just tell you those because I used to like those names. Deuterium is that one, and this one is called tritium. And both these elements are actually quite easy to come across on Earth. Certainly deuterium, and tritium is actually a byproduct of doing fusion. So the waste products you can actually then use to do more fusion, which is pretty useful. But yes, so what you do in the jet facility, so that thing that I showed you before, I'll just bring it back one more time because it's a pretty cool video. And yeah, in the end, potatoes were actually relevant. Where is it? Here we go. Yeah, so what's going on here is something called magnetic confinement, where you let the where you use a super strong magnetic field to let let's get rid of that again. Use a super strong magnetic field to spin hydrogen round at incredible speeds around this donut shape. So the hydrogen goes round and round this massive donut shape. Just get rid of that. Hydrogen goes round and round this massive donut shape at such incredible speeds that it thinks it's at high pressure. It thinks it's at high pressure. So in order to build a star, what you need to do is take small elements like these, and you need to get them going at an unbelievably high speed, round and round and round and round and round and round, so that you using magnetic fields to constantly deflect them in a circle, and then using the high speeds, you can convince them to start smashing into one another at such a high speed that they think they're under high pressure and they can turn into heliums. And that's how we build a star on Earth. And to do this also, you need a load of other cool things, like you need heat sinks to get away the ridiculously high heat that you're creating in doing so. Anyway, right, I can see that there are loads of questions, so I'm just going to skip down to this gingerbread slice. Oh my god, the gingerbread shop. It's my favourite, literally my favourite place in the whole of the UK is this gingerbread shop in the up in the north called Grasmere Gingerbread. Grasmere Gingerbread Shop, and it's just reopened for sending gingerbread in the post, which is really great because it's bloody delicious. Anyway, right, let's just see what people are saying on here. So is there a star on Earth, is what Mariella is asking, and the answer is kind of yes, because the jet facility south of Oxford is basically acting as a star. It's taking loads of small elements and it's squidging them together to do fusion under high temperature and pressure, and it's using that to create energy. Now, the jet facility is still not creating enough energy. You actually still have to put more energy in than you have to than you get out, and that's one of the big problems. That's one of the things that we're working on. And the next one that's going to be built is one called ITER, which will be the first fusion power plant that will actually give out energy rather than just consuming it, which will be good. One thing I wanted to ask before we finish, do you guys think fusion sounds dangerous compared to fission? So just for those who don't know, Let's go up to here. Fission is the opposite end of fusion. So fission is when you take big elements like uranium and you chop them into bits. So you convince uranium to break into other bits, and because it becomes smaller elements, it will release energy on the way because it's becoming more stable, and that's nuclear fission. So that's what people normally do when they're talking about nuclear power. Which do people think is more dangerous, fission or fusion? And Jasmine is asking, where does hydrogen with a neutron occur? As in, where can you get it naturally? There's loads of, if you're asking where do you get it from, so Jasmine's asking about this thing called deuterium. There's loads of it in the sea. You can quite easily extract it from the sea with fishing. Yeah, thanks, Miz. And fission sounds less dangerous, says Jeff. I think fusion is more dangerous, says Roxy. Okay, so both of these things require lots of radiation shielding because both of them are nuclear reactions and they both give off dangerous radiation. However, we know how to shield those things and we know how to stop that radiation from getting out. In fact, did you guys know that you will experience more dangerous radiation stood inside Grand Central Station in New York than you will stood right next to a nuclear power plant? Because nuclear power plants are not allowed to give out the amount of radiation that's being given out by the granite that station is built with. So neither of them are really dangerous in terms of their radiation just being given out. What matters is, can they enter an irreversible chain reaction and enter a meltdown? And the answer is for fission, so that's like uranium. As you guys will know from the stories of Chernobyl and so on, and the meltdown in Japan, obviously fission can enter a chain reaction and can become a disaster, whereas fusion can't do this. It's so difficult to maintain the speed and heat that you need to keep the star going that as soon as something goes wrong, the whole thing just turns off. And that's why it will hopefully be a lot safer, hopefully give out a lot more energy, hopefully be a lot cleaner, because rather than producing radioactive uranium, you're just using different forms of hydrogen and you're creating helium. And the helium produced is not radioactive, in fact, some of it might be radioactive, but also much easier to dispose of because it's a very light gas that can just float to the top of the atmosphere. Anyway, so I'm going to have to finish there because we've gone like a full 8 minutes over. But does anyone have any last questions that they want to throw in before we finish? Any suggestions for future lives are always welcome because I'm planning loads at the moment and I want to make sure they're ones that you guys want to hear. And let me know if you want me to focus on stuff that's closer linked to certain things you have to do at school or not. I'm happy to do stuff that's like interesting, but also like telling you the kind of stuff that you need to know. And yeah, thanks so much for coming. Do spread the word. AimHi Live is the Instagram. AimHi Lives is the Facebook. And I think we're not quite on TikTok yet, but we're going to be. And yeah, thanks so much for coming along. Do throw any last comments. Oh, wait, there's some last questions. What does fusion actually contribute to? So Roxy's asked that. Fusion is, well, it will be a power source once we can scale it up enough. At the moment, it's still a research project, so we haven't got it to the point where it's producing enough energy, but eventually we'll be able to get rid of like coal and oil and power stations and all those kinds of things and have fusion instead, which will be a good form of energy, especially like for things like space travel. Fusion could be good. A big ideal for me is getting way more renewable energy. That would be brilliant if we could have that instead. But for now, fusion is something that looks like it could be quite important to help us to avoid fossil fuels. And Sam's asking, how do I get involved in a career in nuclear fusion research? Such a cool question, mate. You got to try and take like a physics degree or like a mechanical engineering degree or something like that. But those kind of like physicsy engineering degrees are the way to go. But try and contact the people at JET. They're really friendly. Roxy wants to know more about singularities, and Josephine wants to know more about radioactivity. Okay, cool. I will do more stuff on that as well. Thanks so much for coming, everyone. And oh wait, Mariella's just asking what train station's more radiation than near a nuclear power station. That's Grand Central Station in New York. Check it out. Thanks for coming, everyone. I'll be back again at 2 p.m. tomorrow, and there's someone else going after me at 3 p.m. tomorrow who's going to be really cool as well. Thanks so much, guys. See you tomorrow. Ciao.